Good morning. My name is Mick North. I'm the CEO, President of Anderson Global. This morning I'm talking to our engineering manager, Ben Plouhar, and the topic is reverse engineering. And we're going to discuss what Anderson's capabilities are in this field. Good morning, Ben.
Good morning, Mick.
All right, tell me what we got.
So many times customers will come to us and they have some outdated tooling, lost tooling, but they have an order for a casting that maybe was old, that they need to make some new castings. When the volumes are low, you can get away with 3D printing cores nowadays, but when the volumes increase, you would like to go back and create some tooling for the foundry so that they can create the castings in a cost efficient way.
Yeah, even if you can 3D print, you still need the model of the component, right? So if you don't have the model, you have to be able to create the model.
That is correct, yes. So many times a customer will actually send us a machined casting, a raw casting, so that I can measure finish stock, make sure that I'm getting that all in the appropriate places. In addition to sending me, as you can see here, kind of shown step by step, they send us the casting, we go through, we scan it on our CMM with this line laser scanner, and then we will create the 3D model off of the scan and any other information pertinent to the part that they would have supplied. Like for example, on this specific one, they also supplied us a 2D print. So in conjunction with the 3D scan, we'll also go through and check off and check dimensions to the boss dimensions in particular to make sure that they line up in the end. Now, okay. One thing you have to realize on a casting, it's not always exactly the way that the initial casting was. So when the casting comes in, you might have some shrink differences. It might not have shrink to the exact dimensions. So that's why you will take the in conjunction with the drawing and the scan to create the best possible model with the agreed upon deviations with your customer.
What that looks like on the CMM.
So once the casting is supplied to us, we put it into our CMM. As you can see, as an example, this part will come in. This is just a tooling part that we happen to be scanning. It's just an example, but we would take the casting that you would see here and we would scan it from multiple directions. Sometimes if there's cavities or passages for water, oil, you name it, air, sometimes we have to cut that section after it's scanned, rescan the sections, and then you will take all of your STL information in the scan geometry, and using what we have is Design X Geomagic, we will bring in all of the STLs and we'll take and align them together before we're able to start to create the 3D model. But once we have everything aligned inside of it, then I am able to begin to create this 3D model off of the scan geometry. Now, working with Design X in conjunction with NX, which is our primary design software, we are able to work back and forth. Design X actually will allow me to connect directly to my NX file, and I can feed that information back and forth. So as I'm working through it, I can check the color mapping and determine that the proper scale and the proper tolerances are met for each individual part.
Okay, maybe you want to just explain what the different colors are that we're looking at?
So on this particular one here, when we turn on the color mapping, as you can see here, there's a scale factor on the right. Right now it's set to plus or minus 0.1 millimeters, which is plus or minus 4 thousandths of an inch, which is very tight. Typically for a large casting like this, our target is plus or minus 20 on something that they're just trying to get a new casting. That is partially due to the fact that the casting is not to its actual net because it is a casting, right?
Mm-hmm.
So you would change the tolerancing over on the right side to become 5 millimeters, say, as you're going, and you can see how as everything begins to turn green, which means that it's in tolerance band that we set. So working back and forth between NX, Design X, being able to pull surfaces off, sections, we would then create that model completely in NX, as you can see here.
So when you laser scan something, typically there's areas that are less well defined, I think. Shadow areas, difficult to get at. How have you dealt with those?
So in certain areas, sometimes I may have to have the casting cut in that area, and so the scanner can get at it from a different angle.
Oh, physically cut.
Yes.
And opened up. Okay.
Exactly. There's definitely lots of areas, and you can see that from the scan inside of here when we're looking at that. That some of this, like you can see where the holes are, means that the scanner didn't pick it up.
Yeah.
But some of these areas for what I was doing were not that important in those specific areas because I have enough of the surrounding shape in order to be able to create the necessary features for that casting. But if there was like a specific, sometimes I'll have a casting that has like a hole that's coming through here or a passage that leads into another one. The only way to get that is to scan the entire casting first, so I have a full model that I can align the rest of the scans to. So I would take this one, it would come in, we would then physically cut this casting in half, and then we would rescan that section of the casting, and then I would bring that STL back in, and everything would begin to line up, and I'd be able to get that internal shape or the hard defined shape.
Okay.
So once we go through and we have an acceptable model, typically on ones that then provide us, let's say, a 2D print, we will then go back and create our own 2D prints of each one, just so that we can, as just an additional double check, just to make sure that everything is okay. So we would then create our own drawing based off of the one that we supplied. So in conjunction with the STL scan, the 3D model that I created, and the 2D print that they supplied, we would then verify that all of the information has been captured correctly. Then we would review that with the customer, make sure that they're okay with it, get an approved casting model, and then from that casting model, we are able to then design the tools. First step on this particular foundry, we're having a 2-on core. This is the coat pattern. It has coat and drag patterns.
Yes, and as we discussed at the beginning, the other option could be that a 3D printed tool could be created from that model if the volume's low.
Yeah, exactly. If in fact at this specific point you have two options. You can either design and build a tool for it. Sometimes even for like a mid volume, they'll have tools for it, but the material might be a softer material. If it's go into a production and they want it to last for a long time, and they're going to have it as a a steel material that's hard, it's not going to wear as much. But if they only need a couple castings, but they need that casting, they could then also 3D print and pour directly into those.
Yeah, and just so our customers know, we don't have that type of 3D printing capability, but we have a couple of partners out there that do that for us. And we've used that to produce prototypes for customers, and then go on to machine those prototypes as needed as well.
Exactly. The part comes in kind of, as you take a look at this slide, kind of explains it all. As the part comes in, you take the casting, you get it scanned, create the 3D model, verifying back and forth that we're matching the acceptable tolerances. We'll work through that with the customer. And once that is approved, we have, multiple options to create tools or prototype parts or packages, things like that.
Okay. Perfect. Thanks, Ben.
All right. Thank you, Mick.